My name is Pasha Finkelstein, and today I will talk about data and testing of data pipelines. Initially, this talk was prepared together with Ksenia Tamak. She's, to shame, she's not here today, but I will try to do best to present it to you. I'm developer advocate for big data at JetBrains. I fell in love with data like 4 years ago, and today I'm going to talk about less popular aspect of data engineering, of working with data at all. Today we will have several topics related to data. For example, there will be a talk about pandas, but usually people do not tell you how you should test and how you can test your data pipelines. If you like this talk, you can subscribe follow me on Twitter. I'm Asmodio there, or at Mastodon, I'm Asmodee at fostodon.org. Also, my nickname is in the left bottom corner of each slide. Let's move. So, data processing, data engineering is all about data processing. What is data processing? Very simple. We take some data, maybe we will modify it a bit, or we'll allow it to be as it is, and put it in some other place. For example, we can get some data from Kafka and put it to Postgres. It's your usual data engineering pipeline. Of course, in real world, data engineering pipelines work with several layers of data. For example, Databricks introduces 3 types of layers of our data: bronze, silver, and gold. Bronze is just as raw data, as you get it from your Kafka, Postgres, MySQL, or whatever. Then silver layer is a layer where you have clean and not aggregated data. And on the gold layer, you will put already aggregated data, data that can be consumed by your real consumers, your customers, your, I don't know, data scientists, data analysts, marketing people, product owners, management, whatever. And as I said, people usually don't say that everything there should be tested somehow. But it should, because we are doing something useful for business. Probably we should test it. The most well-known part of, well, lesser known part of testing is a pyramid of testing. Is it pyramid of testing? Yeah, kinda, but not really, because what we usually call pyramid of testing is this thing where you have 3 layers of tests: unit tests, integration tests, and end-to-end tests. Unit tests are very fast, and you have to have lots of unit tests, and it's white box testing. It means that when you write unit tests, you know how your code works. Integration tests, we have less tests of integration kind, and it's a black box testing. And end-to-end tests, they're very long, they're usually hard to write and hard to maintain, but on the other hand, they test the whole application through its, I don't know, happy paths, unhappy paths, but it's not just spare parts of application, it's the whole application. Let's start from unit testing for our pipelines. Yeah, unit tests will test some small part of our pipeline. For example, transformation of data from bronze to silver layer, from raw to aggregated. Let's imagine some very simple pipeline. We have some input, for example, CSV. We can map it, reduce, aggregate in some way, and put it some output. For example, Parquet file or CSV again. Both are fine. How will it look in Python? Like this. For example, in PySpark, we will define schema of our data. We will say that we want to read data with such schema from some CSV source. I'm sorry. Then we will map it, reduce it, and then here I say show. But of course, we can say that we want to write it to CSV, or we want to put it somewhere. Anything, any terminal operation will actually finish our pipeline. How will we test it? Well, and what we should test it? we should test that this pipeline works correctly. And here I should say that correctness is a business term. It's not that our pipeline doesn't fail with exception. It's that in business terms, it does what it should do. How can we do it? Well, that's very simple. We will extract this map, reduce, and aggregate together into a separate function. And then we will put some fake data into our first step, and we'll look or check what's going out from the last step of our small pipeline. There are some helping projects to do unit testing. In this case, it's for Spark, but there are lots of other frameworks, and I can just put all the tools that will help you to test your to unit test your pipelines. So for Spark, they will be Spark Testing Base by Holden Carrall and Spark Darya by Mr. Powers. For other frameworks, you usually don't even need special tools. You can just put some list into your function and get some list from your function and check if it works correct. So the next step is a component or integration testing. Component or integration tests are tests where you check that not your whole system works correctly, but some part of your system works correctly. For example, let's say that our pipeline reads data from Postgres or puts data to, I don't know, Oracle or whatever. We already have unit tests that say that the pipeline itself, logics of pipeline, works correctly, but it's not enough. We should check that it can really work with our real-world systems, that it will really work in, for example, with our Postgres. How will we do it? The answer is simple. Answer is test containers. Test containers is basically the very simple thing. It allows you to, instead of putting some fake data as input to a separate function, it allows you to take some Docker container and interact with it. In our case, most probably, it's read to it or read from it. But also, of course, we can put some data in our Docker container into it and check if everything is fine there. Test containers support many languages. I mean, many. Java, Python, Go, Node.js, Rust, .NET, Scala, and probably I forgot something. I believe there is a support for all popular languages in test containers. How work with test containers looks from the Python perspective. First of all, we import container we need. Folks from test containers have some predefined containers: Postgres container, MySQL container, Kafka container, whatever. Sometimes we need something different. I don't know, let's say Aerospike. In this case, we will have to create a generic container with Aerospike. But here I will talk about Postgres because it's a very, very frequent case. Then we, using with operator, we create Postgres container. And inside this with clause, we have a full access to our Postgres. We can get connection URL. We can call some SQL alchemy queries to it. We can for example, we can call version equals result fetch one. It's a SQL alchemy syntax, and get a version. In this case, it will be obviously 9.5. What is the actual version of Postgres? I believe it's something like 15. So yeah, these days it should be already 15. But then when we have all this component tests, it's still not enough, because we are not sure that our application works correctly, right? We're only sure that parts of our application works correctly. And in normal software development, in usual software development, there would be end-to-end tests at the top of the pyramid. But in data engineering and building data pipelines, it's not that simple, because First of all, we have lots of data, and usually we can't mock our real systems. For example, let's look at this slide. Here we have some not too complex pipeline. We have some external data. We put data into Azure Storage Blob. Then we move data to Azure Synapse. Then we move data to analysis service, and then we visualize our data in Power BI. It's everything there is orchestrated using Azure Data Factory, and of course there is some authentication with Azure Active Directory. Well, thing is, we cannot emulate anything of it with Docker. It's proprietary stack of technologies. And when we use cloud providers, and these days we most probably use cloud providers, we don't have any ability to mock these providers or to replace these providers with Docker containers. Sometimes we can try, because Azure Synapse is like Microsoft SQL, but it's not. It's actually different. It's set up a bit different. It has different configuration options, and so on. So sometimes we have to test on real systems without any Docker containers, without any stubbing, mocking, and so on, because we are vendor locked. We have vendor locked databases, processes, and so on. And also sometimes we rely on external error handling. For example, on Splunk, we have to know that our Splunk error handling works correctly. So part of our end-to-end testing will be performed not on some synthetic environment, but in real production system or very production like. The second Himalayan peak, do you see, it was pyramid, but now it's kind of peaks. That we have to test on real data, because data is changing over time. And it's an issue too, because we have a big data, right? We have probably terabytes, petabytes of data. How will we do it? Yeah, look, you usually can't really test on the whole pipeline, on the whole data set we have. We should select samples. Here I have like 5 batches of data. I select 2 of them. I anonymize this data, like I can, in this example, I convert Pasha Finkelstein to John Doe. Then I process my data through my usual pipeline. And then I call some check function that will try to understand if data is transformed correctly or not. The other way to test on real data is the same sampling, but using anti-join. What is anti-join? We take some samples of data, we process it and get some result. Also, we have prepared reference result, like how it should like, and then we perform anti-join on the data. What is anti-join? Anti-join is operation opposite to join. It finds different rows in our data sets. Result of anti-join can look like this. For example, we need to find the gender of a person who is using our e-commerce shop right now. It may be important for our recommendation engine, because even if the gender is written on profile, maybe, it's usually the case that one spouse is looking for clothes for other spouse or for children. And for our recommendation engine, it should be important. So yeah, it's how anti-join results can look like. Gender found is man, reference gender is man, ID is 1, and it's matched. That's fine. Okay. But for the second row, the expected gender is child. The actual gender found is female, and this data doesn't match. Maybe we should fix something. Maybe we just broke our pipeline. Maybe something different happened. Maybe we should adjust our reference data set. However, we can put our our data. We should put this on our pipeline to check everything on our CI pipeline, and CD pipeline. Also, of course, we can sometimes deploy full data backup on staging environment and minimize it, and then run our whole process of transformation on it. But probably it will cost an awful amount of money. But if you are rich, it may be really your case. But usually it's not. Usually companies try to save money, and I fully support and understand them. Okay, let's talk about testing a bit. In usual testing, in testing of usual backend or front-end applications, you won't trust your code and you test your code. In data engineering and in testing data pipelines, it's more complicated because you won't trust both your code and your data. So, and it means you have to test your data too. And what we usually test? We usually test what will happen if I will have an empty data set as input. What will happen if I have a valid data as input? But what we usually forget to test is what if my data is invalid, or what will happen if the data format is illegal and input? It actually happened once to me. We just silently dropped input data sets because they were in illegal data format. And it led to the situation where we dropped like 2 months of data. And we suddenly realized that our models do not learn anymore. And it's a very bad thing. To avoid it, we have actually only 2 options in data engineering world. We can use library called Great Expectations, or we can use DQ. They all are built to create real data expectations. Like, we know how data should look, but we are not sure what it really looks. They can profile data, they can give you some suggestions on constraints, they can get you some metrics, and they can even store some metrics. Let's talk about Great Expectations. First of all, okay, let's say we have some schema. We have 3 fields in our data set, should have 3 fields in our data set: ID, sale date, and country. In our input data, we have empty country, Russia, Kazakhstan, and Austria. Why not? Then we can create data frame, and that's all. In Great Expectations, oops, it looks like, I'm sorry, folks. It looks like I accidentally dropped several slides, but in Great Expectations, we will create a data frame based on this Spark data frame, or there are some other methods to do it too, and ask, is our data correct? And Great Expectations will give us a result. Look, actually, your test is not successful at all. Success false. We have partial unexpected list. We have Austria and empty country in our data set, and it's incorrect. And this means that half of your data is incorrect. And you can make your conclusions based on it. You can say that, okay, maybe my data is wrong. You can say that maybe my expectations is wrong. Again, the best part, you can put it into your data pipeline and analyze what's going wrong and fix something. For Python DQ, it will be kind of the same. But Python DQ, what we should know about Python DQ, it's heavily bound to Spark. It won't work with anything else. And for me, it sounds bad because Great Expectations are unbound from our frameworks. We can use Great Expectations in a completely independent way. For Python DQ or for DQ at all, we can use it only for Spark. And actually, it's very simple. We say that we want to run our check on data. We check that country is contained only in Russia and Kazakhstan, and then we ask it to show us verification result, and it says something, it gives us a table like this. For me, honestly, it's just not enough. What did you find there? What did you find there, DQ? Why half of my data is incorrect? Great Expectations is much more verbose, and thus, for me, it's much more reliable and useful. Still, if you are into Spark, and if you are fine with these limitations, Python DQ may be can be much easier integrate into your pipeline because you're already familiar with these old technologies. You don't need to learn Great Expectations CLI and its API actually too. Let's talk about real use cases. How can we build where can we use our real data expectations? We can use them on pre-ingestion and post-ingestion data validation. It means that we can either validate data that we did not ingest yet, we didn't consume it, to check if we should consume it. Or we can consume data and say, hey, look, something is going wrong now after we consume the data. And both are working. It strongly depends on your use case. We can use it before even pipeline development. You can profile your data to understand which corner cases you should think about when you are building your pipeline, because you will already know the nature of your data. We can use it for monitoring and alerting. If one day something bad will happen inside your pipeline, you will see it, because Great Expectations will say, okay, look, something is going wrong. Some metrics is invalid, and maybe we should say something about it. The next Himalayan peak is kind of hidden. It's not a testing per se, but it's very important too. In real production, we should monitor things because we can't cover everything with tests. Monitoring is very important, and it's kind of testing in production too. And also, data tends to change over time. What does it mean? It means that if we won't monitor something, we'll just skip this moment when we started losing data, and our data amount grows exponentially. Both are wrong. We should know what's happening to our data. And yeah, here we are talking about what we can monitor. We can, of course, monitor data volumes, counters, which is data volumes is like a physical size of your data on your hard drive. Counters is, for example, numbers of rows. Time is an essence. We should measure how much time it takes to run our pipeline. We should monitor dead letter queues, and of course, we should monitor service health and business metrics. We can do it with separate different ways, for example, with listeners in Spark, with data aggregations, or with Airflow, because Airflow has built-in monitoring actually. And also we should remember that data pipelines is always a DAG. That's how Airbnb monitors the pipelines. They have these nice charts for each step of their graph of their pipeline, and they always know what's going wrong on which stage. And also we have kind of end-to-end tests based on monitoring, because we can monitor data latency, performance, and scalability. And speaking about performance is very important, because if one day our data pipeline will take multiple times more time to finish, what we will do about it? Well, we can at least try to measure how much time it takes to run our pipeline. And also we can use this scheduled task that will check if everything is going fine inside our final destination. Let's summarize what we heard today. We have this huge pyramid of testing in data. At the very basement, we have unit tests, and they basically cost $0 per item. We have component tests, which are a little bit more expensive. With test containers, we should bring up some Docker and so on. Let's say they cost $1 per item. We have real systems testing. They kind of cost us money. Let's say it's some $2. I don't know what does it mean. It's like bigger amount of money, and we can test with real data, and it's much more expensive because we need to understand how to sample things. We need to understand a lot. Also, there are two hidden peaks of testing: monitoring and performance. They don't cost us anything because we work with them anyways. We can't avoid it. But still, there is some real cost I'm just not talking about. So testing pipelines is like testing code because we have unit tests and component tests, and at the same time, it's not like testing code. Pipeline quality is not only about testing, it's also about monitoring, performance monitoring, different metrics, and so on. Sometimes testing outside of production is tricky, and we have to test in production. That's all I have for you today. Again, here is our handles in Twitter and my handle in Mastodon. If you have any questions, you are welcome to ask them.